Our next example is the matrix 0, 1, 0, 6, 0, 0, 8, 3. So when we look at this one, there are no rows that consist entirely of zeros, so condition 1 is automatically satisfied. So now we check condition 2. The leftmost non-zero element in each row should be a 1. So in row 1, we have 0 and then 1. So we are good to go there. In row 2, we have 0, 0, 8. So since the first number that is not 0 is an 8, this violates condition number 2. And remember, I want a 1 there. And to get a 1, I multiply by the reciprocal. So we're going to use the command 1/8 R2 to replace R2. And that will give us a matrix that is in reduced form. Okay, now we're going to use row operations to change the matrix to reduced form. So once again, we're using those conditions and we're using operations to get this in the form that we want. So first of all, in this matrix, with row 1 being 1, 0, negative 2, 1, row 2, 0, 1, 3, 0, and row 3, 0, 0, 5, negative 20, there are no rows that consist entirely of zeros. So we're good to go there. So let's check now to make sure that the leftmost non-zero element in every row is a 1. So row 1 and row 2 both satisfy that condition. Row 3 is the problem. We have 0, 0, 5. We need 0, 0, 1. So we need to change that 5 to a 1. And we're going to do that by multiplying row 3 by the reciprocal of 5. So 1/5 row 3 will replace row 3. And when I do that, that's going to give me a new row 3 of 0, 0, 1, negative 4. So now I've got the conditions for the reduced row echelon form satisfied for condition 1 and condition 2. So now I check to see that third condition. Where the leftmost 1 is in any row are zeros in the rest of the column. So if I look at column 1, I see that I have 1, 0, 0. In column 2, I have 0, 1, 0. So column 1 and column 2 satisfy the condition. But column 3, I have negative 2, 3, and 1. So I need to get zeros in the places where negative 2 and 3 are. So remember, when I'm trying to get zeros, what I'm going to do is I'm going to multiply the row that has a 1 by the opposite of what I'm trying to replace and add it to it. So if I'm trying to get rid of a negative 2, I want to add a 2 to that. So I'm going to use 2 row 3 plus row 1 to get a new row 1 of 1, 0, 0, negative 7. And to get rid of the 3, I need to subtract 3. So I'm going to multiply row 3 by negative 3 and add it to row 2 to get a new row 2 of 0, 1, 0, 12. And now all of my conditions are satisfied. The Gauss-Jordan elimination method systematically transforms an augmented matrix into a reduced form. The system corresponding to a reduced augmented matrix is called a reduced system. And this method is named after Carl Friedrich Gauss and Wilhelm Jordan. So here is the procedure. First, we're going to choose the leftmost non-zero column and use appropriate row operations to get a 1 at the top. Then we're going to use multiples of the rows containing the 1 from step 1 to get zeros in all the remaining places in the column containing that 1. And then we're going to repeat step 1 with what we call the submatrix, which means we basically ignore the row we used in step 2 and all the rows above it, and we work with that submatrix that we have. And then we repeat step 2 with the entire matrix, including the rows deleted mentally, and we continue until we're in reduced form. So this is really easier seen in an example. So we will do that in just a moment. One thing to note, if at any point in this process we obtain a row with all zeros to the left of the vertical line and a non-zero number to the right, we can stop because we have a contradiction. We can then conclude the system has no solution. We will look at an example of this so we can see what we mean here. So we're going to solve this using Gauss-Jordan elimination, and we're going to use x1, x2, and x3 as our variables. So we have 2, 1, negative 3, negative 3, 3, 24, negative 63, 27, and the last row is 1, 5, negative 13, 5. So first, I want to get a 1 in the upper right corner in position 1, 1 if I can. And in this case, I notice that I have a 1 in the bottom row. So what I'm going to do is a row interchange. I'm going to interchange row 1 and row 3, and that's going to put my 1 in the row 1, column 1 position. So my new row 1 is 1, 5, negative 13, 5. Row 2 stays the same. And row 3 is now 2, 1, negative 3, negative 3. So we now have that the leftmost number in row 1 is a 1, leftmost non-zero number, I should say. So we need to get zeros below. So we're going to change the 3 and 2 to zeros by multiplying the 1 by negative 3 and negative 2 respectively. So negative 3 row 1 plus row 2 gives us a new row 2 of 0, 9, negative 24, 12. Negative 2 row 1 plus row 3 gives us a new row 3 of 0, negative 9, 23, negative 13. So now let's move to row 2. The first non-zero element needs to be a 1. So that means we need to change that 9 to a 1. And when we need a 1, we multiply by the reciprocal. So we're going to use the command 1/9 R2 to get a new row 2 that is 0, 1. Negative 24 over 9 reduces to negative 8 over 3. I always recommend reducing your fractions if you have them. And 12 over 9 reduces to 4/3. Now condition 3 says we need zeros above and below that 1. So we need to change the 5 to a 0 and the negative 9 to a 0. So we're going to use negative 5 times row 2 plus row 1. That gives us a new row 1 of 1, 0, 1/3, negative 5/3. Row 2 stays the same. And we're going to multiply row 2 by 9 and add it to row 3 to get a new row 3 of 0, 0, negative 1, negative 1. So I've looked at row 1 and row 2, and I've got the zeros above and below the 1s. Now we're moving to row 3. So I have 0, 0, negative 1. So I've got to get a 1 in that spot. And since it's just a negative 1, I just have to multiply by a negative. And so that just changes the sign. So I get a 1 and a 1 in those last two columns. And now I need zeros in the rest of the column. So I'm going to use the commands negative 1/3 R3, add it to row 1 to get 1, 0, 0, negative 2 as my new row 1. I'll use the command 8/3 row 3 plus row 2 to get a new row 2 of 0, 1, 0, 4. And so now I see that I've got this in reduced form. So notice that this tells me that x1 plus 0x2 plus 0x3 equals negative 2. so x1 is negative 2. 0x1 plus 1x2 plus 0x3 is 4, so x2 is 4. And 0x1 plus 0x2 plus 1x3 is 1, gives us x3 is 1. Or you could write this as a parentheses with negative 2, 4, and 1. For example 5, consider the matrix with row 1 being 2, negative 4, 1, negative 4. Row 2, 4, negative 8, 7, 2. And row 3, negative 2, 4, negative 3, 5. So notice in column 1 there are no 1s, so we can't do a simple interchange like we did in the last one. We're going to actually have to just manipulate row 1. So I need the first non-zero element to be a 1, so I need to change the 2 to a 1. So I am going to multiply by 1/2 and get a new row 1 of 1, negative 2, 1/2, negative 2. Now I need zeros everywhere else in the column. So negative 4, row 1 plus row 2 gives a new row 2 of 0, 0, 5, 10. 2 row 1 plus row 3 gives a new row 3 of 0, 0, negative 2, 1. So moving right along, looking at the next row, I've got 0, 0, 5. So the first non-zero number is a 5. We need it to be a 1. So we're going to have to multiply by 1/5 row 2 to get a new row 2 of 0, 0, 1, 2. Now remember, I need to have zeros above and below the 1. So I need the 1/2 and the negative 2 to become zeros. So I'll use the command negative 1/2 row 2 plus row 1 to get row 1 being 1, negative 2, 0, negative 3. And I'll use 2 row 2 plus row 3 to get 0, 0, 0, 5. Now notice the last row here says that 0x1 plus 0x2 plus 0x3 equals 5. Well, 0 is never equal to 5. This is a false statement. This is an example of a no solution.